And now it's time to use Terraform to deploy EC2 instances. To do this, we'll make use of the AWS instance type resource. Let's call the resource as web server. This resource expects two mandatory arguments: the AMI, which is the AMI ID in the US West 1 region where we want to deploy the Ubuntu instance. The second is the instance type. We want to deploy a low-spec instance with just one CPU and 1 GB of RAM. So we'll opt for a T2 Micro general purpose instance type. Optionally, to identify the EC2 instance, we can add tags to it by making use of the tags argument, which is a map. Here, we have added two tags in key value pairs. The first is the name with the value of web server. The next is the description, which has the value of an Nginx web server on Ubuntu. We can also pass in an entire bash shell script to be run when the instance is launched. To do this, we'll make use of the user data argument and the here doc syntax, like this. We can now use the Terraform plan and then the apply command to create the web server instance. Alright, so we now have the instance up and running, but how do we access it from our client machine? Since this is an Ubuntu EC2 instance, the logical answer would be for us to make use of an SSH client and then connect to the server. But what is the IP address of this machine? And how do we allow SSH access to it? And which SSH key do we use to connect to it? We have not specified any of these in our Terraform configuration, and as a result, by default, we cannot access this from our client machine. In the demo, where we created an EC2 instance from the management console, we created an SSH key pair just before launching the instance, and we used this to connect to our server. Now, let's see how to do that with Terraform. Let's go back and update our Terraform configuration. To do this, we'll make use of another resource type called AWS key pair. This resource makes use of an existing user-supplied key pair that can be used to control the login access to the EC2 instance. There's only one mandatory argument called the public key, and here we are making use of the file function to read the contents of an existing public key called web.pub, which is stored in the local machine running Terraform. Alternatively, we can also provide the contents of the web.pub without using the file function, like this. Next, we can specify this key within the AWS resource block by making use of the key name argument like this. Now that we have added the key-based access control to our configuration, let us look at the networking that will allow users to connect from the local machine to the port 22 on our web server via the internet. In our demo, when we deployed the web server manually, we saw that we used the default VPC and one of the available subnets for the EC2 instance. Think of VPC as an isolated network within your AWS infrastructure. And within this isolated network, we can deploy services. With a VPC, we have the complete control over the IP address range that can be assigned to a resource, such as an EC2 instance. And we can also allow and restrict access to this resource from other resources within the AWS cloud or even the internet. In the demo, we also created a new security group called SSH Access, which, as the name suggests, allows SSH access from any source by making use of the 0.0.0/0 range. We then use the security group while creating the web server instance. Although this is not a recommended approach in a production scenario, this configuration will allow us to access the Ubuntu web server from the internet, as long as we have the private key. Now let's do the same with our Terraform configuration. We will deploy this instance in the default VPC and subnet as in the demo, but we will create a security group that will allow ingress access to port 22 from the internet. For this, we have to make use of another resource type called AWS Security Group. Let's call this resource as SSH Access. The name and description are optional, but we will give it some meaningful values such as SSH Access for the name and a suitable description. Now that we have added the resource block for the security group, we have to apply it within the resource block for the EC2 instance. To do this, we'll make use of the argument called VPC security group IDs and use a reference expression to specify the ID of the security group that we just configured. This argument expects a list, so make sure that the values are supplied within square brackets like this. And while we are at it, let's add an output variable to get the public IP address of the web server instance. We can use this later to SSH to the web server from our local machine. If we rerun the Terraform apply command now, we will see that the key pairs and the security groups are created, and the EC2 instance is recreated because of the change in its configuration. Once the resources are created, we should be able to SSH to the web server instance using the private key like this.